So let's start looking at the chapter probability. This is the chapter number 16 of the class 10th CBSE textbook. Now, in this video, we will just look at the chapter. We'll just survey the chapters to see what topics are there. So this chapter starts with the introduction, and if you look at what we are going to talk about is the what you have already studied in the class ninth, which is known as the classical theory of probability. Okay. And you could also say that this is called statistical approach of probability. Now what is it? We will look about it. Then they talk about what another theory that was developed by a Russian mathematician called A.N. Kolmogorov. So this is what was developed in 1933, proposed by this Russian mathematician, and this is the basis of this chapter, right? And what we are going to study in this chapter is going to be called as axiomatic approach of probability. So the key idea here is what you learned in class 9 can be called as classical theory of probability or the statistical approach to probability, and the one that we are learning is known as the axiomatic approach to probability, which was developed by A.N. Kolmogorov, a Russian mathematician, in 1933. So that's the introduction to this chapter. Now, before you go into the details, you have to understand some of the terminology before you can understand the axioms. So we first start with what is the meaning of random experiments. So we will look at that. Then we will look at the meaning of what do you mean by outcomes and what do you mean by sample space. Okay, and there is also a word called sample space of the experiment. Okay, we will look at what is the meaning of a sample point. So these are just some of the keywords that you need to just familiarize yourself with. We will of course look at the details of this later on, and then we will have examples on this terminology. So just one example so that you can understand what kind of examples will come here. Like two coins, a 1 rupee coin and a 2 rupee coin are tossed once. Find a sample space. What do you mean by the sample space of this event? Right, we will look into problems like this, and then you can see the first exercise is really related to finding the sample space for various experiments. Okay, so that will be your first kind of topic. Then we look at the meaning of the term event. Okay, what do you mean by event and how do you represent the event for a sample space? Okay, then there are some examples. You can see there is a definition. Then we look at the occurrence of an event. How do you say that an event has occurred? How many types of events are there? And we will look at an impossible event. Then we will look at what do you mean by so this is an impossible event. What do you mean by a sure event? Okay. Then there is the other type of event is a simple event, then a compound event. So simple, as you mean, is just exactly and simple events, whereas compound events is not, I mean, it will probably have more than one sample point. So we will go into the details, right? And now here is the interesting thing. Just like we learned addition, subtraction, multiplication, division of numbers, we did that with algebra. In the same way, we could do operations on the events, and that is what we call as algebra of events. So we will look at how we start playing with these events. Okay, and we will look at what is a complementary event, what happens if you want to talk about the event A or B, then the event A and B, two events occurring, then the event A occurring but not the B occurring. So these are some of the what you call algebraic properties of the events that we will consider. And then there are of course problems that we will solve. Then we will look at what is the meaning of mutually exclusive events, what are exhaustive events, and how do you define them, how do you represent them. Okay, and then that will bring us to the exercise on the events. Okay, then it is only after looking at the meaning of those terms that I told earlier about the sample space and the events, we actually start the axiomatic approach to probability. Now you will start seeing that some of the areas, like you have such kind of axioms, axiom 1, axiom 2, we will understand what does it mean. And the meaning, the mathematical representation of this probability axioms, as well as how we can apply them. Okay, so that's what we are going to do. Then we'll define a probability of an event based on the axioms. Then we will look at probabilities of equally likely outcomes. Okay, then we will look at probability of the event A or B. So this is kind of getting to the algebra of events. Okay, and then the probability of an event that not A, means one of them doesn't happen. Okay, then there are going to be problems based on that. Okay, and as we move along, you can see that we will have a whole set of assignment for the based on the axiomatic probability theory. Okay, and that will then, kind of almost conclude our chapter. We also have some miscellaneous examples for people who would really like to go into a little bit more detail of it. So I think that is what this chapter is about. Like, basically, I would say that there are three main topics, the key topics. The first one obviously being the meaning of sample space. Then you look at the events, and then we really look into the axiomatic theory, approach to probability, and solve some of the problems based on that. So that is the crux of what we are going to discuss in this chapter.